Yeah, hello everyone. Thank you so much for joining us this afternoon too. This session forms part of AREN's Promoting Reproducibility in Africa. Of course, the sessions are open to everyone across the world. We've done a few sessions already, promoting reproducibility in the biological sciences, and we are doing this session on promoting reproducibility in the computational sciences. Speaking to us today is Miguel from the French Reproducibility Network, which is part of the Global Federation of Reproducibility Networks that AREN is also a member of. So Miguel, over to you.
Okay, well, thank you very much. Well, first of all, thank you, Lamis and Emmanuel, for the invitation. So I have prepared this talk that, well, I have a lot of slides, but I think I can do it in maybe 45 minutes, where I will present a little bit of an introduction to computational reproducibility, that it's something that most of the members of the French network are doing. And we'll discuss also briefly about some of the challenges that we find when we try to do reproducible research the computational way. Yeah, just to introduce myself, I am a researcher in France at this school. It's called Normal Supérieur. And I belong to a lab which is called the Central Aurélie. And as Emmanuel already said, I belong to the French. So let me also introduce very briefly about the French Reproducibility Network. It's a network which is quite new, I guess, as most of the networks. It was launched in 2022, and we started with some conferences. There has been like 150 participants in different places in France, like Paris, Grenoble, and other places. And we have the support of the French Ministry of Higher Education. And I would say a lot of members working at different aspects of reproducible research. So we are organized. Well, there's a steering committee, and we have several working groups like notebooks and trainings and software environments and others, and some other groups that we call colleges that have different missions like scientific events, international affairs, where I belong to, institutional affairs, and bibliographic monitoring. So just to finish with this introduction of the French network, we have some connections with the National Committee for Open Science, with initiatives which already exist, like some MOOCs, for example, with local networks, which have an interest also in reproducible research, and we try to be in contact with different doctoral schools to offer courses and seminars. As part of the training activities of the network, there are two MOOCs produced by the INRA Learning Lab. INRA is like the Computer Science Institute in France. And well, there are those two. I'm not going to go into the details. One is more focused on documentation and replicability, and the other on big data and heavy computations and software environment. Okay, so if you want to know more about the French network, there is this mailing list that you can join there, and you'll receive some information. And there's the email of the network that if you want to reach us, you can use. So let's move now to the topic, which is computational reproducible research. And I'm not going to introduce all these terms that you already know, I guess, and like repeatability, reproducibility, well, all this that was started at this article, the ACM1 artifact review and badging of the different versions. What I'm going to do is to translate these terms in our context of computational sciences. Reproducibility for us is running a program in the computer and obtaining exactly the same results bit by bit. Or when you have algorithms that this is not possible, you say that you want to obtain equivalent results. And replicability is for us is following a detailed procedure and implementing this program, not because you have the code itself, but because you have the instructions on how to build it. In our terminology, normally we speak about pseudocode. So it's not exactly source code, but it's a high-level description or very detailed descriptions in a paper. Then we have, of course, the concept of repeatability, that it simply means that you are able to perform an experiment as many times as you need to obtain results. For example, in computer science, well, nowadays, many researchers are using neural networks to obtain results. You can think about ChatGPT, or many of the methods which are based on neural networks. And you can repeat. You have this architecture, you put your input data and you get an answer, and you can repeat this as many times as you want. It's not always the case. Imagine that you want to analyze with a computer the data which comes from the collision of two black holes. And this creates, now we know gravitational waves, but it's something that you cannot repeat. Okay, just to tell you that, yeah, sometimes you can, sometimes you cannot do that. When you want to analyze the reproducibility, again, in the context of computer science, you need some elements. You need the source code of the method, or if you have all the detailed descriptions, yeah, you could arrive yourself to the source code. But in any case, you need a source code. You need all the data which is associated to the method. For example, for neural networks, it is the learning data or any initialization data that you need to run the method. And yeah, in general, any data. So you should be able to obtain exactly the same results. This is reproducibility for us. And you'll see that just simple things like having the source code, sometimes it becomes a challenge. It's not something that we as researchers, we don't have access all the time. So yeah, this is a fair challenge. For example, when you analyze a paper and you have a pseudocode, which is great, but inside the pseudocode, you don't have all the details, or maybe some initialization steps are not given, or typically the source code is not available. And sometimes you ask the authors to give the source code, and they don't want to do it, or they don't answer for plenty of reasons. Or even if you have the source code and all the specifications, sometimes you don't have the learning data. What's the problem with this? If you cannot obtain results, other researchers cannot compare with your method. And if we are researchers and we have methods like this, actually, we are not sure about the method. So in that case, we should believe that the method works as intended. But science is not about believing. It's we should be able to check. So this is one of the first challenges for reproducibility, not having all the elements that we need. So let me put an example so you can see how important is reproducibility. Okay, this is a real example, and there's David Donoho. It's a statistician in Stanford University. In 2009, he wanted, well, he started pointing out a credibility crisis in scientific research. And well, after he said that, there was the director of oncology of Amgen, which is a American pharmaceutical company. Okay, this director tried to take 53 of the most important papers on oncology and try to reproduce the papers, the most important. And he failed miserably. So 47 of them were not reproducible. It doesn't mean that these papers are false. It's simply that you cannot arrive to the same conclusions. Most of the time, the papers are true, the conclusions are correct. It's a technical problem that then I should believe what the paper says, even if it's true, but I cannot check it. Then some time after, Bayer in Germany tried to repeat this, and they found that only 1/4 of the cancer research is reproducible. So you want to learn more, there's these articles in Nature that give all the details. So you can see it's not for granted reproducibility. And the big problem is that if you cannot check the results, you need to believe them, and this is not what we want to do. Then, of course, there are different disciplines like biomedical, biology, social sciences, or computational sciences, as we are doing at this moment, myself or the French Reproducibility Network mainly. But reproducibility, it's something that you can apply to many different disciplines. Of course, these many different disciplines, they have their own requirements and different protocols. And the thing is that for some of these disciplines, it can be more challenging to arrive to reproducible research. For example, when we speak about biology or medicine, one challenge is that having really exactly the same conditions like temperature or pressure or whatever physical condition in the lab can be very difficult, if not impossible. However, in computational sciences, we don't have this problem. So I would say there is no excuse that we don't try to arrive as far as we can to reproducibility, at least in computational sciences, is still is complicated, but it's more doable. Nowadays, we have a lot of algorithms which are non-deterministic. It means that with the same input data, the output is correct, but it's not always the same. For example, I don't know, when you have an LLM, for example, a large language model like ChatGPT, maybe you ask exactly the same thing, and it can answer slightly different with the different words. This kind of algorithms are called non-deterministic. Sometimes, if they really depend on the initial conditions, I don't want to get very technical, they can be called chaotic also. And this is typical for neural networks. So can we perform reproducible research with them? So this is yet another challenge for us. And the answer is that in that cases, you cannot compare bit by bit because the answers will be always different. However, if you remember at the beginning, I said there is a replicability, which is a part of reproducibility and we are interested in following a procedure and obtaining results. And these results, they don't need to be exactly the same. They need to be valid or equivalent. And this is something that we can do with algorithms which are not deterministic. Means, for example, here I mean that statistically, the results should be equivalent. And then there's a question, which is the one that you can read there, is if a reproducible research is so great and so useful and so needed, why we are not all of us doing reproducible research? And if it's not that complicated for reproducible, for computational sciences. And there are some reasons that we could identify. First is that we know that not all the researchers, they want to make the source code public. And there's plenty of reasons for this. Most of the time is that you are working with your code and you are changing your code every day. You publish and then you are not sure to which version of the code your paper corresponds to. Some people think that the quality of the programs of the source code is low, it's low quality, so it's better not to release it. This is a mistake. So it's always better to release the source code even if the quality is not the top. But not releasing source code is pretty bad for science or and of course for reproducibility. And another reason that we could identify is that if you want to add some quality to the software, because you said, okay, I'm going to release my sources, and but you want that it's something decent, let's say. So it means that you need to spend time on testing, documenting, adding quality metrics. I mean, this depends on how far you want to go, but just documenting and testing takes time. So of course, if you don't release the code, you don't need to do that. So that's one of the reasons some researchers don't release the code. And then you have other reasons that are worse, like for example, if you have a method and your method is not that good, and you try to hide the fact that the method is not as good as you wrote in the paper, then of course you don't want to release the source code so others can check. So something that it's always been identified, and I think it's true, is that we as researchers or researchers in the computational field, actually any researcher, we are valued on most of the time on the number of papers that we submit and get accepted. And some software is not at the same level of consideration. Here I wrote, is considered a second-class citizen. So many times it's considered like a supplementary material and so on. So it means that if making software or making it reproducible takes a lot of effort and it's not really considered, that's kind of stopping people investing in reproducible research. It's not all bad news. We have some good news, like for example, the French government, they have this plan for open science. And inside this plan, there's a path 3, which says that we should be opening and promoting source code produced by research. So it's something. At the European level, we have EOSC, the European Open Science Cloud, which emits recommendation to the European Commission. So it's not specifically on reproducibility, it's more generally on open science, but of course, if you want to do open science, you need reproducibility, so it's good. And I can give you I can tell you about other challenges that we have on computational reproducibility. And for example, I can tell you about the challenges that we have when we need to review papers which are supposed to be reproducible. And we have some prerequisites. First is we need a detailed procedure for the compilation and the execution of the code. This is not always the case. So when you see a paper which has some code and this is not given, it's problematic. This is one challenge for us. The execution environment, this is super important, and it's again, it's a challenge because you have the source code, you can compile the source code, so you have an application that you can run in your computer, but it's not running by itself, it's just running inside what we call an environment. To put it simple, it's not the same thing if I run this program on Linux, or if I run it in some version of Windows, or if the libraries are different, so the results can vary. So something that we always need to do, it's a challenge for us, is when we run a code, a program, we need to fix exactly the same environment to be able to compare. And another challenge that we have is that I said you download code and you compile it, but which version of the code? In some papers, you might see a link to download the code, for example, to GitHub, and you don't know which version of the code this corresponds exactly. So we have some solutions to this. I will introduce later briefly the suite, the Software Heritage ID. So we have some challenges and some solutions. Then not only for the software, but nowadays most of the methods work with data, especially neural networks. So as soon as we have data, we have some problematics like we need that the data has some attributes like findability, accessibility, interoperability, and reusability. I will tell you quickly what this means, but we need to have this, and in short, you say that your data is fair when you have all this. So to explain it quickly, findability, it means that I should be able to, as the word says, to find the data easily. For example, in the paper, maybe they say, this is data set with this code, numerical code. So normally with this code, I should be able to find the data easily. Or they would tell me, go to Zenodo, which is a platform which stores data, and put this code, and I will find it easily. Accessibility, it's something that we also need. Accessibility, well, at different levels, but to put it simple, imagine that I have a link to download the data. If I use the link and I can download it without registering or doing anything, we could say that the data is accessible, so it's great. On the other hand, if I use the link and the website tells me to, I don't know, to pay or to register or to give my email or whatever, so put in obstacles so I can get the data, we say that is not accessible. Interoperability means that the data should be encoded in a format which is standard and does not depend on a particular software. So if I download this data, I should be able to read it and to operate with it normally without having to install some proprietary software, let's say. And reusability, it means that once I have the data, I should be able to do several things with the data. For example, to modify the data, to improve it, or make it available again, which is not always the case. So it depends most of the time on the license that the data has. But when we have findability, accessibility, interoperability, and reusability, when we have this, the data is fair and it's suitable to reproducible research, which is not always the case, but sometimes it is. Then I don't want to go into the details or very technical details, but another challenge that we have in computational replicability, I would say, is when you have a paper and with pseudocodes and you have the source code, something that you need to do is to check if these descriptions correspond to the implementation. So the implementation is the actual source code. And this can be very challenging. So to read software, you need experts on reading the software, the source code, that at the same time can read the source code and can understand the mathematics or the technicalities of the method itself. Then there's a bunch of things that we always do when we review, like checking that we don't have hidden hyperparameters or magic numbers that appear there, which are not explained. We have challenges about the names of the source code and the pseudocode names of functions or variables that they don't match. The kind of comments that we have in the source code. Well, I don't want to go into the details of this. I think I can skip this. Maybe I will say a word about optimizations. And optimization is, it's writing the operations of your algorithm in a way that it runs better. So better means maybe it runs faster or uses less memory. It's better. However, these modifications that you do to make it better might create differences with what it's written in the paper. So the result will be the same, but when you try to compare or to understand what those are doing, it's not that easy. So that's another challenge for us, the optimization. And I think that's it. Then I can tell you also briefly or give you some recommendations when you need to write a reproducible article. Recommendation, or you can see this as our challenges if you prefer. And a first challenge, as I mentioned before, is that not always the source code is available. So that's the challenge. So the recommendation is, of course, make your source code available, and don't worry if the quality is not the best. Nobody will judge you because of that, because I think everybody would understand that you are not a professional programmer, so you are a researcher making code, which is kind of different. So it's not that bad if the quality is not the best. However, making the code available is good. And luckily, you have some solutions for this. You can use GitHub or GitLab. Nowadays, we have also software heritage that comes with some advantages, like you will get version tracking, easy referencing, and permanent archiving for free. For data, we have solutions also. There are public repositories where you can put your data that will be stored ideally forever there. And for example, if you use this one, which is called Zenodo, they will make your data firm, which is kind of good. And the challenge and some solutions is controlling the environment. So this is something that you always need to do. However, there are solutions like gigs or NICs, which are complete operating systems that control very well the dependencies and the environment. You have like virtual machines or lightweight virtual machines and a bunch of other programs that will help you control your environment. Then another challenge that we face now and then is the format of the data. So as you can imagine, if I download data and this data can only be read with some software, it's a problem for me because first I cannot read the data directly, so I need to buy this software. And once I buy the software, I don't have any warranty that this software is maintained or the format won't change and so on. So it is a challenge. It is a problem for us when people don't use standard formats, but we have solutions. There are many formats which are open that you can use. And data sets, as I mentioned before, if you produce a data set, it's very important that the data set is encoded in a format which is standard, and you can put it in another, and it's great for the community. I think I will skip this about code quality. So the idea would be don't worry that much about the quality of the code. So simply release the code as soon as it's ready. And yeah, I have some minutes, so I will finish by showing you some initiatives at the French level that they are linked to the French Reproducibility Network that I think it's interesting to show you. And if you are interested in any of this initiative or others that you can find in the website of the French network, we could organize for you maybe a session of about any of this. Anyway, I will just show you very briefly so you can have an overview. Something that the French Reproducibility Network is working on, it's notebooks and literate programming. I would say it's mainly working on literate programming, and the way you implement this in practice is with notebooks. For those who don't know, literate programming is a way of presenting code, source code, in a way that you combine not simply instructions for the computer, but you add blocks with natural language or figures, which are very pleasant for the reader to understand the code. And the way to implement this is with notebooks. So I don't have a picture of a notebook there, but you can look for Jupyter notebooks, for example, or Google Colab. These are examples of literate programming. So we have a working group in the French network, which is working exclusively on this. So is the working group notebook. So these people are leading this group, and it's actually it's an open group. So if you, I guess you can join them if you are interested in the topic. And yeah, notebooks are important for, especially I would say for communicating results. So it's very easy to have explanations there in that natural language, and I mean, and to show to others is a very direct way to transmit the knowledge, and also to let people play and change the code and see the results. I think it's a great way. Another initiative is started before the creation of the French network is this project Software Heritage. So Heritage is a huge project. So it's a project supported by UNESCO and other organisms. And what they do is to preserve source code. When I say preserve source code, I mean preserve all possible source code which is publicly available. So as soon as they find source code in GitHub, for example, they make a copy and they assign a proper identifier for it. And their mission is to store this, to keep a copy of this code forever. It's something that I personally agree with, because now I think we take this for granted, the fact that we have a code and the code it's always available. No? If I put my code in GitHub, it will be there for the long time if I don't remove it. But GitHub and these platforms for code management are very recent, and it's quite dramatic. But if you think about the quantity of source code that we have produced, the humanity, let's say from the 40s, 50s up to today, I would say that from the 90s, yes, we preserved well the code, but if you look at code from the 50s, 60s, 70s, 80s, beginning of the 90s, all this source code is lost. I mean, not all of them, but most of this code is lost because nobody tried to preserve the code. And it's like if I told you, imagine that all the books before the 80s were totally lost. So, of course, we cannot compare with books. It's not the same. It's not the same thing. but source code, it's production of humanity. There's a value, and yeah, it's good to preserve it. So these are just to show you some of the sources that software heritage scans and get information from. So from Git, Bitbucket, Debian packages, many places. IPOL, which is the journal that I belong to, the updates code from there, from HAL. It's the French repository, institutional one. Live, a journal, so it takes all that of the code and stores it. And it's huge. You can see that nowadays there's billions of source code or files, millions of commits stored, and millions of projects, which is good. So they are safe. They, and it's supported by India, in France, UNESCO, and a lot of different institutions and companies. They're helping. Sort of what the way and Google, GitHub, and many others are helping. And yeah, it's quite open. So if you have some source code or in GitHub, probably Software Heritage will have already found it and make a copy. Otherwise, you could go there and tell the Software Heritage, hey, here's my source code, and make a copy, and they will do it for you. And something that came with software heritage, which is great for reproducibility, is this suite. So this is the software heritage ID. So what's that? This is an identifier which points to source code. So as you can imagine, this is super useful for reproducibility because this identifier points to a copy which is permanent, so I don't have the risk that I'm pointing to something that maybe next year it doesn't exist anymore. It is decentralized, and what's that? Because it's not software heritage who creates these identifiers, but these identifiers are computed from the contents of the code itself. So nobody will assign something. So you have a file, you can compute the identifier yourself, and it's valid. So this is great because we have identifiers which are very proper, and they can point to different levels of the source code. We call it different granularities, and points to permanent objects. When software heritage started to propose this kind of identifiers, there was the idea that it should be a standard because, we are in open science, so we don't want to reuse formats that are controlled by a company or by an organism. Should be something really standard and agnostic for everybody. So something that Software Heritage was working on is to make a standard. And very recently, they managed to have it. So the Software Heritage ID is an ISO standard. So it means that, yeah, it originated at Software Heritage, but it doesn't belong to Software Heritage. You can use it with Software Heritage, but you can use it in your own repositories if you wish to index source code. So that's a good step towards reproducibility and open science. And I have some minutes. I will be very brief now. I mentioned that controlling the environment was another challenge. So we have initiatives at French level also that help controlling the execution environment. One of them is GIGS, which is a derivative of another project which is called NIX, but GIGS is adding something, some particular tools that are very useful. And well, it started some years ago. It's a complete distribution, and it has a very special, takes care of this controlling the environment and the dependencies between packages. I don't want to get very technical again, but if you are interested, maybe we can ask some people at Geeks to give a talk. They can explain more. But if you have a big project and you want to ensure that everything is consistent and you can reproduce results using Geeks is good. And I will finish showing you very, very briefly two initiatives, which are scientific journals, totally focused on reproducibility and replicability. One of them is the Free Science journal. You can reach it by freescience.github.io. It's focused on, you can see here, on replication. So it means that for them is that the method is totally new is not the most important. The most important is that you have a method and following a procedure, you can have results. So they are making reproducible or replicable versions of works that might already exist. And it's totally open, so you can have here the latest publications, and of course it has an editorial board. And if you are a reader, here you can access to the contents per year. If you want to create an article, you have the submission procedure. And another initiative is the iPod journal. I am one of the editors of this journal. So like the science, it's focused on reproducibility and replicability. So we publish reproducible articles. It's totally open, so you can come here and access the methods. For example, if I come to this method, what we have always is the PDF that you can download. You have always the source code that you can download without any restrictions. So you don't need to register, you don't need to do anything. You just go there and you obtain a copy. We have this index with software heritage with the suite, so you can point to pieces of the source code, and it's a copy that will be there forever. You can have a preview of the article, or you have the PDF here. And we added something. We added for each of the methods an online demo that you can upload your own data or use data that is there. So here I just executed this method with this image of the two parrots, and I can see the results, and I can see metrics and so on. So we have this for every method which is published. And we keep an archive of experiments that we think is super useful for others to see if the method is working well, or working as expected or not, or maybe if there are some unexpected results. So each time someone comes to iPod and tries the method with a new image, we keep a copy of the results. And I think that's it. So here. And go to thank you very much for your attention.
Yeah, thank you so much, Miguel. That was a very wonderful introductory session. I think the French AREN is doing wonderful work. It looks like somehow computational reproducibility experts came together and you started it and you've entrenched it with a lot of initiatives. So that's really wonderful. So the floor is open for questions from our attendees here. If you have any question, you can raise your hand and unmute yourself and then ask your question, or you can post it in the chat. So the floor is open. We have about 10 minutes, approximately 11. So we have about 10 minutes. So if you have any questions, you can just go ahead and ask. Before anyone comes to the floor, Miguel, do you think it is difficult to achieve computational reproducibility in a resource-limited setting, or that does not really affect it?
No, it depends. For example, in my lab, we do a lot of image processing and computer vision methods. That actually, if you look at the algorithm, you see that you don't need much to run. It's mainly mathematics that you do with a pencil and a paper. and then implementing the algorithm, decide short algorithms. Normally, yes, even with limited resources and many methods, you can reach reproducibility. It's more a question of the effort that you need to write the code and to ensure that things are correct and so on. Then it depends a lot on the method. If you think about modern methods on AI, for example, they need big data, they need months of training. So it means that your lab needs to buy several GPUs. So yeah, so some labs maybe are not. Unfortunately, they don't have the resources to do this. So I would say it depends a lot on the methods. So maybe for more modern methods, it's more challenging, especially if you have a very large neural network that sometimes you even need a supercomputer. So yeah, I would say not all the methods are as simple, but yeah, many methods you can do reproducible research. It's not that challenging. It depends.
Okay. Okay, so I think from what you said, depending on the complexity of what you're trying to do and the resources you need, I think you said that a lot of them are quite simple and straightforward, that you could easily apply some of these principles. And then when you were talking, you mentioned AI. Do you think AI is a tool that can be used to improve reproducibility of code? Or do you think now it's not reliable?
Uh, as a tool, yes, well, why not? I mean, I think that AI used as a tool is great. For example, I used a lot ChatGPT to find information, to organize information. So why not? It's a routinary work that I would have to do. So if I have a tool that can help me with this, it's good. For example, for reviewers analyzing code, having a tool that can guide you a little bit, or maybe telling you that your analysis has some problems that you are not aware of, it's good. I think the key is to use AI as a tool to do your work, not to substitute you doing your work.
Right.
So, because of course, you will make mistakes, and the AI will make even more mistakes. So if you use it as a tool, knowing that it can fail, I think it's good, but not letting AI do all the job. That's a bad idea.
Yeah, that's true. I think now I'm not sure if AI now has reached a point where we can really extensively rely on it when it comes to making code better. I don't know if you are aware of any tool. Do you think there is any tool out there that you are confident that maybe programmers and computational scientists can use to improve the reproducibility of their code?
Um, I don't know if AI. What I would suggest to any researcher is to look for checklists, not with AI, but simply checklists of things that you need to look in your code if you are complying with it or not. Things like, do I have a license in my code or not? This is something that many people forget to add a license. Or maybe they think if I don't put a license, it's okay because it means that I don't care what people do. But in reality, what you are saying is that I'm not putting a license, so everything is forbidden for you to do with my code. So, I mean, having a checklist, I think it's good. Then, can AI help you with it? Probably yes. I mean, if you ask an LLM, okay, here you have my code. Can you check? Probably it will check things like, do you have a license? Mm, I don't know, you have comments in your source code or not, you have an identifier, your code is in GitHub, you have a version number. So probably, yes, there are things which are very routine that you need to do. So yeah, having a machine helping you with that, I mean, if it works, why not? So as long
Yeah.
as it's a routine, yes, it can be useful.
Yeah, great. So that is more like guided work, right? You have a checklist and it's kind of helping you do
Yeah.
that guided work. Not necessarily, like you said earlier, substitute what you are supposed to do. I think there is a question in the chat. It says that what is the scope of research reproducibility networks? I think it's a question for myself and also for you, Miguel. So I'll answer from the side of AREN, then you can also answer from the side of the French AREN. So yes, the scope is broad. I think AREN, our community is open for everyone. Anyone can join. And we normally have a sign-up form that you use to join our community, and you just give details about yourself. I think currently the larger percentage of our community is coming from the life science or health and biological sciences, but we have social sciences in our community. We have people coming from the engineering and a whole lot of other disciplines, the humanities and etc. So it's open. You can join, and there's not a limitation as to who can join. But I think maybe with the French AREN, Miguel is a computational expert, and I think a number of them that really the people that are really active within the AREN that puts everything together also specialists there. That's why that is the case. But I think I'll leave it to Miguel to comment on that.
Yes, I think probably all the reproducibility networks we share the same values. Some of them are more specialized on some areas and with respect to others. And if I had to choose something that I think is very useful, in particular for the French network, but I think probably is the same for everybody, is that you put together people. For example, with the French network, we are putting together software heritage or the NICS people working on this, controlling the environment, journals, and I think this is good because otherwise, these people or journals, NICs, software heritage, they could be working on their corners, like alone, working, doing a very good job, but without being necessarily aware of what others are doing or not at the same level. No? If you put everyone together and they feel that they belong to the same network. I mean, that's good because they share data. Or like we are doing now, no, we share the same values. So it's a pleasure for me to do this talk, or if there's any project we can collaborate. So I think inside the networks it's kind of the same. You put people together, and people are willing to work together to do things.
Yeah, that is great. Let me see if there is any other question. I think someone asked a question. I'm not so sure what that means. Giselle, if you could unmute yourself and ask the question, so we could get more clarity. Giselle Tefera, can you unmute yourself? It looks like he can't. The question says that which comes first, research or resources? Which depends on, yeah, has he unmuted himself?
Research or resources.
Yeah.
Yeah, I would say that research comes first in the sense that you seek knowledge. Okay, this is normally the motivation for research. There are phenomena that you don't understand and you would like to understand, like in physics. You observe the universe and you say, I don't know how this works, and you do your research and you try to understand. I think is the will to try to understand this comes first. Then yes, you are limited by resources. But if you have the resources and you don't have the will to understand or to make real research, I don't think it doesn't work. So I would say first is research, then you are limited by resources.
Yeah, that is great. Lamis has raised the hand. Yeah, Lamis.
Yeah, thank you so much, Miguel. This was really, really nice and really enjoyable. And it's nice to see that, I come from the biological and life sciences, but it's nice to see that, the principles are the same, basically. And when it comes to reproducibility, it's just trying to document your work as much as you can and write details about your work as much as you can. But I guess my question comes about because I did my PhD in France, so I know INSERM is one of the biggest labs that are all over France. So are you starting to see such big labs and stakeholders starting to acknowledge and reward reproducible research, or is it still like far ahead? Are they still, because I saw in your talk you said that you know many still depend on the numbers rather than the quality. But I was wondering, when it comes to computational sciences in France, the encouragement to using reproducible research or not?
Yeah, I think, well, in general, also in computational sciences, it's starting to have more and more value. The problem I see personally is that it advances slowly. So I think if you ask French institutions at this moment if reproducible research should be valued, no, or having some impact on your career, everybody will say yes. If you produce reproducible artifacts, we need to take it into account. So that's why the first government created this plan for open science and so on. So yes, it is taken into account. Then if you have a look more in detail, you'll see that still the most of the weight comes from classic metrics, like how many articles did you have, how many projects did you supervise, these kind of things, and giving some weight to reproducibility. I, my opinion, it should advance faster, that it's advancing at the pace that it goes, but I think it goes in the right direction. In biology, I don't know how it works exactly, so I'm I'm more in the computational field. The computational field advances slowly, and it's having importance, but it could be it could go faster.
Thank you, Miguel.
Thank you.
Yeah. Thank you so much, Miguel. I don't know if there are any other questions. Are there any other questions? I think we've run slightly ahead of time. We apologize for that. I think there are no hands raised and there are no mics unmuted. So I would assume that there are no questions and we can end the meeting now. Miguel, once again, we want to say a big thank you to you and the French AREN for agreeing to facilitate this session. It's been wonderful. I think pulling all our expertise together is what the Global Federation is for. So it's been wonderful to have you here. To everyone here, this was more introductory. I think that is why Miguel was skipping some of the slides and he wasn't really going into details, because this was supposed to be quite introductory. The French AREN has been doing a lot of sessions that are more practical, more detailed. So I shared a link to their website. You can go to their website and then subscribe to their mailing list and get updates on some of the sessions that they are doing. When we receive them, to try and share it across our community so that you can join some of these sessions and then learn a bit more about reproducible practices in the computational sciences. So thank you everyone for joining. And Miguel, thank you also for this wonderful session. Have a wonderful day, everyone. Yeah, bye-bye.
Thank you so much. Bye-bye.
Bye-bye.